In this video, we're going to take a look at three forms of an equation that would be helpful to deal with. The first isn't really a form of an equation, but it's a good place to begin. It's something called direct variation, and this concept is used a lot in equations for science, so that's why it's important that we at least kind of touch on it. The second form of an equation, or the primary form of an equation, something called slope-intercept form. This is your y equals mx plus b. This is probably the one that is most widely used. The third form that I'd like to cover is something called point slope. This is the y minus y1 equals m times x minus x1, the quantity of x minus x1. This one is not used as much as slope-intercept, but it sometimes is a little bit quicker and easier to use to try and get something into into slope-intercept form. It just sometimes is quicker just to use this equation and then simplify it. So let's touch on these. When we begin to look at direct variation, the primary equation that we're going to take a look at using is this y equals kx. In this, the y-intercept is 0 because I'm adding 0 here, which means that the graph will always pass through 0, 0. K is what is known as the constant of variation. So when it talks about how does something vary, what's the constant of variation, it's just your K value. And how this is transferred to slope-intercept form is this K value will also be the slope of the graph. A lot of times, in order to figure out what K is, we look at what's your Y value divided by your X value. So this is sort of the primary, remembering K is also the slope. Think about your slope, which is your change in Y over your change in X. Keep in mind the graph will always pass through 0, 0. So in a sense, your K is equal to any Y value minus your 0 over X minus 0, which is why it simplifies down to Y over X. Okay. The terminology that is generally used is it'll say that Y varies directly as X. So that's pretty much what you're looking at. What's your Y over your X, okay, value. So you're basically just dividing Y divided by X. If you know something is paired up, figuring out what your constant of variation is, you have an equation then you can use to solve. Slope-intercept is probably the most famous and most widely used. Once again, M stands for slope, B stands for y-intercept. Once I know that this stands for slope-intercept form, I have a quick way of graphing something like y equals x minus 4. If I can identify the y-intercept as being negative 4, I got 1 point on the graph. And then if I know that my slope isn't written, which means it's 1, what that means is I go up 1, over 1, up 1, over 1, up 1, over 1. I could also go down and to the left 1. Anyway, I begin to get a nice straight line. So look, I have it graphed. It's quick enough. What I can also do is look at a graph and come up with with an equation. In this case, I know that my y-intercept is 2. So I can say y is equal to my slope, which in this case is going to be down 2 and to the right 1. So it's going to be negative 2 over 1, which simplifies down to negative 2x. And I know that my y-intercept is at 2, so I can do plus 2. Now this works nice and easy because I can tell easily what my slope is, and I can tell very easily what my y-intercept is. Sometimes it's not as clear, which is why I have this something called a point slope form. Basically where this point slope form comes from, whoops, sorry, that should be a 1 there, y minus y1, is it's basically taking the slope formula, dropping off the subscript of a 2, because remember those are arbitrarily chosen, leaving the y and the x as is, and subtracting the 2. So in this equation, what's important to realize is this y and this x always stay. I'm never going to plug anything else into the equation for that x and y. They will always stay as y and x. Okay? This x1 and this y1, I will substitute in. Okay? Based off the point that you have, that you're given. And for this equation, what I also want to make sure is I plug in the slope. So you must have a point and you must have the slope. So if I give you an equation, okay, let's say I give you something looking like this. Okay. Okay. Looking at this, I have 2 points on the graph. I do not know my y-intercept, but I know that I have a point at 7, 6, and I have a point at 2, 2. So I can very easily figure out my slope. I can either do 6 minus 2, which is 4, over 7 minus 2, which is 5, or I can kind of use the graph to say I go up 4 and to the right 5. So I know my slope. I have 2 points at this point. So what I'm able to do, oh shoot, I don't want to do that. Okay. What I'm able to do, let's go ahead, I'm going to, shoot, I can't do that either. Okay. What I'm able to do is substitute in the values into the equation. That I could have y minus, and I could, let's start with this point, y minus 6 is going to equal the slope of 4/5 times x minus 7. Looking at this, this is not going to come out pretty. Y minus 6 is going to equal 4/5 x minus 28/5. Okay. The 6 I'm going to think of as being, I need a common denominator of 5. So it's going to be minus 30, or plus 35ths. This is going to be plus 35ths. So these will cancel out, they're the same value. So y will equal 4/5 x plus 2/5. Okay, so I never could have gotten this y-intercept from the graph, but I can get it from the point slope form. Now you might be thinking, what if I had chosen the other point? So let's go ahead and set it up. Y minus, let's go ahead, I'll use blue just for the heck of it. Y minus 2 is going to equal the slope of 4/5 times x minus 2 as well. I'm going to distribute, and keep in mind that I'm going to need tenths, so I'm going to change, or fifths, so I'm going to change the 2 to minus 10/5, which is the same thing as minus 2, will equal 4/5 x minus 8/5. I'm going to add 10/5 to both sides. So I'm going to end up with y is equal to 4/5 x plus 2/5. Now what you will notice is what I get here and what I get here is the same. Even though what I started with here and here looks different, which is why the point slope form isn't as widely used. But it can be a very quick and easy way to get to that slope intercept form, which is more widely used as kind of like a standardized form, because the answer should always come out to be the same in the end. This line should always be given with that y equals the mx plus b.